My dear friends, welcome to Rajashekhar classes on Applied Data Science with Python. This is lecture number 433. In this lecture, we will try to understand moving window for time series data. So, let's take one of the simplest way of featureization, one of the simplest featureization of time series data called as moving windows or moving window method. Very simple idea. Let's take an example of ECG. ECG is an electrocardiogram which measures how your heart is beating. It measures how your heart is behaving. So I have small example here. I have small example. I have taken this example from MathWorks website. They have some data set for ECG data, and this is how data looks like on x-axis. What we have on x-axis? On x-axis we have time, isn't it? Just check on x-axis we have time. On y-axis beating. I don't know what is the medical term here. Basically on y-axis it is amplitude of a wave. This represents beating of heart. Doctors used to study this and diagnose this. Moving window works like this. It takes a window, just see, it takes a window, a time split from, just if you check, just see this one, this is window. It is a time split. Just what it is, just see, a time split from here to here, isn't it? Just see, from this point to from this particular point. It will take all the data in the window. This is basically, it is a window, a small window of width. What is this particular thing is known as window width. It is a snapshot time, isn't it? It might be time. It might be something like 1,000 units. It's called basically. It is I can say it is a window width, isn't it? What does it mean? If you have wider window, then you will get more signal. If you have a shorter window, then you will get smaller amount of data. Smaller in the sense, for short windows, we will get smaller amount of data. What is the right window width? That right window, correct window width depends on application to application, isn't it? When you are especially work, it always, I can say that window width is always depends on your application. Looking at ECG data or medical data, you should sit with a medical expert. You should always sit with a medical expert, because doctors are medical experts have already learned way of interpreting this data. So we need to learn from them and what they look for. They might look for these peaks. There are peaks. Just see, if you observe carefully, they might look for these peaks. This peak, this peak. They might look for these peaks, isn't it? It always depends on the domain expert, isn't it? They might look for these peaks. You have to look at domain expert. Doctors in this case, medical experts are domain experts. Ask them, what is this signal? What you look at the signal? What are you looking at this? What is their interpretation? Based on that, we can featureize. Some of the standard featureization people do here is they look at a window of time, isn't it? You can sample the data for very long duration also. In this window, what people do here is they only take this window of data. The data is here and they compute mean value. If you have data for that particular window, you can compute the mean value, or they can compute things like I can say standard deviation. Each value that you have in the window put them in a vector. You can put them in a vector, isn't it? And you can compute the mean, standard deviation, extra. That is one way. That is one featureization that you can get with this window. The second thing is you can do median and quantiles. You can calculate median and quantiles. That's the other thing people do. Take a window of time and compute median and quantiles for this window of time. The third thing is that they do is also max and min. Sometimes they take max minus min. Sometimes they take max by min. Isn't it? There are the cases where people may consider max by min. All these are problem specific. That one must understand. All these are problem specific. You need to talk to medical expert and ask them, do these things, are these things are useful from your perspective. The other things called as number of local minima and local maxima. We already discussed even in our previous classes about local minima and local maxima. The other feature could be something called zero crossing. What is this? Something called zero crossing or mean crossing. For this window of data, if this mean value, just let me say this is my mean value. Let me say this is my mean value. Let me assume the mean. How many times? Just let me repeat. If this is my mean value, we have to check whether signal crossing the mean, whether this particular signal crossing the mean. That you have to understand. Let me repeat. The other feature could be something called zero crossing or mean crossing. For this particular window of data, if this mean value, we have to check whether signal crossing the mean, how many times it is crossing the mean. That is called zero crossing. Just say, let me assume this is the mean value. You have to check this signal, how many times this particular signal crossing the mean value. That is known as mean crossing. These are all features that are classical. What are the features? That may be something like mean or standard deviation, that may be median or quantiles, that may be max comma min, that may be max minus min, that may be max by min, that may be local maxima, local minima, that may be zero crossing or mean crossing. These are all features that are classical. You might ask whoever come up with all these features. Typically, all these features are features studied by people in the area of signal processing. There is an area of signal processing where the people used to learn all these things. Those of you who have studied electronics and communication, even applied mathematics, would know about signal processing. So all these features are actually signal processing features. Signal processing is the study of signals like this, time varying. I can say these are time varying signals. This is a very, very old. People in physics, people in electronics and communication, applied mathematics have studied this for a long time. All these are rules of thumb. They are not guaranteed that max or min. Number of max or min, number of crossings. They should always. You should always sit. You should always sit with medical expert or read medical literature on what they are looking for. Of course, you can come up with features of max and min, but you may not correlate it with the class label. But there are many such variations. You must always sit with the domain expert so that you can understand things in correct manner. Just go through this lecture. I will continue my discussion on moving windows in my next lecture also, that is in lecture number 434. Thank you very much.